Hello. Uh, Now our today's topic is writing the real, and the imaginary parts of complex numbers. Here we have four complex numbers. Z1 is equal to 3 minus 2i, Z2 is equal to 5, and Z3 is equal to negative 2i, and Z4 is 2 minus 3i divided by 3 minus 4i. Now, how do we write the real and the imaginary numbers of a complex number is our topic. Now look how we write. As you all know, any complex number z is composed of the real part x and the imaginary part y. So in our case z1, okay, in our case z1, which is equal to 3 minus 2i. The real part of z1 is 3, and the imaginary part of z1 is negative 2, which is a coefficient of I. Okay, negative 2. In the same manner, for b, here we have z2, which is equal to 5. We are told that this is a complex number. Then, if this is a complex number, it has to fulfill this, okay? There has to be real part and imaginary part. Now, this is to mean, okay? Z2 is to mean, okay? Z2 is to mean, if this is a complex number, this is to mean the real part plus 0 times I. So that now the real part of Z2 is as usual 5, and the imaginary part of Z2 is 0, because it's not written. It's 0. Now the same is true for C. Now here we have Z3. This is negative 2i. As usual, a complex number has to be written as x plus yi. But here we do have only negative 2i. This is to mean the real part of Z3 is 0, and the imaginary part of Z3 is negative 2, because this can be written as 0 minus 2i. Imaginary part is this. But now here we have a Z4, which is 2 minus 3i divided by 3 minus 4i. Okay, and let's solve it further. This has no imaginary part, and this has no real part. So, to put this into imaginary and real parts, we have to use something like rationalization by using the conjugate of the denominator. We'll see this in detail. In real numbers, okay? If the denominator is something irrational, we have to go through the process of rationalization. Like if we have 2 root 2, okay? This is irrational, so that we multiply this by 1, which on the other hand is able to pull out 2 from the square root. So now this one can be written as 2 over 2, because this rationalizes the denominator. So 2 over root 2 times root 2 over root 2 is to mean 1, and it has no change on the number, so that this is going to be 2 root 2 divided by 2. Okay, this is in the real work. So in the same manner, we use the conjugate of the denominator to rationalize a complex number that appears as Z4 appears. Okay? So the conjugate of a complex number, conjugate. of a complex number z x plus yi is written as z bar, which is equal to x minus yi, x minus yi. And we simply change the coefficient of the imaginary part to negative. Okay, negative. So here we have z4, whose coefficient is -4. Then the conjugate of 3 minus -4. If we have let's say 3 minus 4i, which is, let's say, z5, z6. Then the conjugate of z6 is equal to 3 plus 4i. 3 plus 4i. Good. So to rationalize this, okay, to rationalize this, 2 minus 3i over 3 minus 4i, we simply use the conjugate of this, okay, the conjugate of this. So the conjugate of this has to be in the ratio of, okay, the ratio of the conjugate has to be 1, so 4i over 3 plus 4i, because 3 plus 4i divided by 3 plus 4i is 1, and as we know, 1 is the identity number in multiplication and division. So multiplying a number by 1 doesn't change the value. Good. So here we have z4, which is equal to 2 minus 3i times 3 plus 4i divided by 3 minus 4i times 3 plus 4i. In multiplying complex numbers, the basic thing you have to remember is the number I, okay, the complex number I is equal to square root of -1. Then I squared is equal to -1. This is the basic matter, okay, the basic matter in multiplying complex numbers. So go through simple product, okay. 2 times 3 is simple 6, okay, simple 6, plus 2 times 4i is 8i, -3 times 3 is -9i, okay, -9i, and -3 times 4, -3i times 4i is, this is -12 times I squared, -12 times I squared. In the same manner, now, as usual, but in simple terms, this is a minus b and a plus b, then a squared plus b squared, a squared minus b squared is the product. But let's follow the procedure we have used. Now 3 times 3 is 9. 3 times 4i is positive 12i. -4i times 3 is -4i times 3 is -12i, and -4i times positive 4i is -16, then I squared. Okay, so here we have 6, okay, 6, this is simple 6, this is equal to, this is 6. Now 8i minus 9i is minus I. Here we have -12, and we said that I squared is -1. Okay, I squared is -1, divided by, here we have 9. Now these are, okay, this is 12i, this is -12i, and this is -16. Okay, -16 times I squared is again -1. I squared is -1. So this is equal to, okay, this is equal to, this is becoming positive, okay, positive, so that 6 plus 12 is 16 minus I, okay, and here this is going to be again positive. So 9 plus 16 is 25. So Z4, rationalized form of Z4 is 16 minus I over 25. So here Z4 can be written as 16 over 25 minus I over 25, which is equivalent to 16 over 25 minus 1 over 25 I. 1 over 25 I. Now it's very simple now here. Here, the complex number Z4 has splitted, okay? This has splitted into real part and imaginary part. Real part and imaginary part. So, real part of Z4 is equal to 16 over 25. Imaginary part of Z4 is equal to negative 1 over 25. Okay? Negative over 1 over 25. Thank you for watching. Do not forget to subscribe, like and share the videos you have. See you next time.